Boom. So we're going to have train 1 and train 2. Sure. Forget freight 1, train 1 and train 2. I didn't read the question properly. I'll call them F train and P train. D, V, and T. Okay. So, what do we know? We know the freight train is going 66 kilometers per hour. We know that the P train is going 90 kilometers per hour. We know that the passenger train has been going for how long? 11 hours. And the F train has been going for X plus 11 hours. You could do X and 11 and then you subtract the 11.
I did X minus 11, but I still got the right answer.
Are you sure you got the right answer? Did you do X minus 11 for the P train? Because this is definitely supposed to be, because it's the 11 hours plus whatever extra time it's been going for. And then the distance they traveled. So we're going to use what we've got for the variables here to write down our expressions. So the distance traveled is going to be what? And the other one's going to be? Which is? 990. Stopped and is done. It was only printing 5 pages.
Oh, okay.
Thanks. And then what is true about these two distances? They have to be equal to each other because one's catching the other. So we're going to have 66x plus 11 equals 990. So 66x plus 66 equals 990. 66x equals 990 minus 66, which I shouldn't need a calculator for, but I do apparently. 924.
No,
is that wrong? Why is that wrong?
66 times 11 is 726.
Oh, that's not 6 times 11, it's 66. 726? Wow. Thanks, guys. Appreciate the fix there. Yeah, now we're going to subtract again. Yeah, the 726. This is a good day. 264 divided by 66. X equals 4. So the freight train has been traveling for 4 hours.
I got X equals 26, and then I did 26 minus 11 equals 15.
The answer should be 4.
Shouldn't it be 15 because it was asking how long it traveled before it was caught up to? Not
Oh, right. So then find the number of hours the freight train traveled before the passenger train caught up. So then we're going to add that to the 11. So it's going to be 15.
Somehow you did the wrong formula, but you got the right answer.
So what did you do?
So I did everything the same, except I did X minus 11, and then I eventually got X equals 26, and so that's right, 15 on top and 11 on the bottom. But I don't know why that worked.
You made mistakes that happened to work out for you. So like the reason there is no mathematically valid reason, Danny, no, for you to subtract 11 at the end.
No, well, I just...
That's the problem.
Yeah, but I
You just...
like minus 11 hours equals 15.
But why did you minus 11? Did you minus 11 hours before or after you looked at the answer key?
After.
Yeah.
Yeah.
Yeah. So because there was no valid reason for you to do that, but you noticed, yeah, no, because you didn't put the X plus 11 in here, you were 11 over.
So,
There's without the answer key, there is no way to come back from the mistake you made.
no.
If you didn't add 11, that's fine. You would have just found that X equals 15. Yeah.
Okay.
There's a few ways you could have done this problem. As you saw, I oopsed. So I probably should have just called this X and we would have been fine. 66X equals 990 and that would have been easier. I made my life way harder than it needed to be. Yes, sir. Yeah, sure, why not? Endaba. That's a wicked name. Left the airport and traveled toward the lake at an average speed of 40 miles per hour. Kali left sometime later traveling in the same direction. This is the same question. This is the exact same question as 10.
Never mind, yeah, the wrong way.
Okay, but I
Sorry, Danny.
did the x minus 2. Should I have done x plus 2?
On 11?
On 11, yeah.
Where did you, depends where you put x.
I put x on the first one. I don't know.
So you did x plus 2 on this one?
Yeah. X minus 2.
Ah, yeah, that's still a mistake, yeah.
But then the same thing I did.
Because you got to think about, the mistake that you're making comes from thinking about who's driving longer. If Endaba is driving longer than Kali, you should not be subtracting time.
No. Okay.
Hold on. There's yes, you want to fix this one?
No, I don't even know how to do this one.
No, that's what I meant. You wanted to fix the question you're asking. Number 9.
I don't know how to do 9.
Jenny left JD's house and drove east at an average speed of 40 kilometers per hour. Michaela left 5 hours later and drove in the opposite direction with an average speed of 55. Find the number of hours Michaela needs to drive before they are 295 kilometers apart. Here we go. D, V, T, boom, boom. Jenny and Michaela. So what do we know? Fill it in. Jenny's going 40. Michaela's going 55.
And then
Hold on. Armand, this is your question, right? Where do you want to go from here? You go to identify a variable somewhere. We have to put a variable somewhere. What do you want that variable to be, and where do you want it? The variable, okay, will be x.
It can be x plus 5 because Michaela left 5 hours after.
So where are you putting x plus 5?
After the time.
For who, though? For Jenny or Michaela?
Michaela.
So she's going x plus 5? If she left 5 hours later, that means she's going 5 hours less than somebody else.
okay.
So then who's x?
Jenny.
Okay. So you want x and you want x minus 5. Okay, cool. So then Jenny's distance is going to be what?
40x.
Good. And Michaela's distance is?
55 bracket x minus 5.
Cool. And then what is the interesting thing about this one? They're going opposite directions. We want to know how far Michaela's got to go till they're 295 kilometers apart. So what are we going to do with their distances, Armand?
Well, they're equal, right? They're even.
If they're catching, they're equal. But they're not catching.
Do you need to add them? Or?
We do have to add them. Because what's happening is this. They both start right here. One goes this way, the other goes this way, and we want to know when they're 295 kilometers apart. So we're going to get J's distance and we're going to get M's distance. We got to add those. That make sense? Okay. So we're going to have 40x plus 55x minus 5 equals 295 when you solve it. Comments? Is that, you're cool with that?
Yeah.
Okay, so we'll stop there. Rebecca, you wanted number 8. We're just slowly going backwards one at a time. Someone named Willie, left the Science Museum and traveled toward the dump at an average speed of 40 kilometers per hour. Danielle left 1 hour later and traveled in the opposite direction. This is the exact same question as question number 9. You will need to. Because they're going, it's one of these, right? Someone's going that way, someone's going that way. Total distance is 220.
Was it x plus 1 on
Okay, guys, please stop. Say that again, Danny.
would it be x plus 1 or x minus 1? I did x plus 1.
Where did you put x is the important question.
Willie.
If Willie is x,
No, Daniel is x. Willie is x plus 1.
Danielle is x, so then Willie is x plus 1. That is correct.
Okay.
A container ship left port 49, traveling towards St. Vincent. A cruise ship left 1 hour later, traveling 1 kilometer hour faster in an effort to catch up. After 9 hours, the cruise ship caught up. Find the container ship's average speed. Okay, so we're going to have the cruise ship and the container ship. So what do we know? Let's fill it in. Danny.
Sorry, you have it the other way. So wait, the cruise ship is going 9, and then the
9 what?
Sorry, 9 hours,
Okay.
and then the container ship is 10 hours.
Because it left 1 hour earlier, yeah.
Yeah. And then the ferry boat that we're trying to find is for the container ship, the velocity of it, or the speed of it.
Yeah.
So that's x. And then I did x plus 1 for the cruise ship.
Yeah.
Is it x plus 1?
Yeah. It's 1 kilometer hour faster. Yeah.
Cool. I don't know if this is okay. And then we did v times t, and we got for the container ship I got x or 10x, sorry. Yeah. And then I got for the cruise ship I got 9 bracket x plus 1 bracket. And then those things. Wait, I don't even know if this is the question I want to question. But
And then those two things are?
they equal. Well, they're equal. Yeah.
Yes.
So then I got. Wait, I think
I'm not sure I know what your question is.
I think this is the wrong one. I thought I needed help with this one, but I thought.
I'm not sure you
maybe
do.
it's a different one.
What did we find for x?
Negative 10.
Should definitely not be negative 10.
But I got the like it's. Because I got. Okay, wait, maybe this is the question. Hold on. Okay. So yeah. Yeah, that's what I need help with. I got
There it
negative
is.
10. So. Oh, okay. No.
We're good?
Yep.
Okay. One more. Anybody else? Going once. Yes, Carmen. Number 5. Abhasra
Yeah, there's a name.
left the Science Museum traveling toward the desert 1 hour before Scott. Scott traveled in the opposite direction, going 10 miles per hour faster for 1 hour, after which time they were 100 miles apart. What was his speed? Abhasra's speed. Abhasra and Scott. DVT. What do we know, Carmen? Scott's speed is not 10. No, ignore the people around you. But what did you do? Oh, it's on. Okay. So then you can tell someone to help you out. Pick someone to help you. Shyla. Shyla, what do we got here? For Scott. Scott is, in fact, x plus 10 because he's 10 more than Abhasra. So that means you called Abhasra's speed what? Thank you, Shyla. So, Shyla, what else did you do? Shyla, would you like to ask someone else? Armand. Coming up clutch, Armand. What do we got here?
I was actually confused on this one too.
Okay. But were you confused on the same part that they were confused?
I was confused on the whole question. I tried to answer it.
Okay, well, so let's talk this one through. We're seeing a pattern here, right? Like, we probably want to figure out something related to the time. So, yes, I know you know. Let me read for a sec. Abhasra left the Science Museum traveling toward the desert 1 hour before Scott. Scott traveled in the opposite direction, blah, 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 for 1 hour, after which they were 100 miles apart. So how long has Scott been driving for, Armand? No, how long? Time. 1 hour. It says right here, he drove for 1 hour.
I looked the way.
You looked the other way? So if Scott has been driving for 1 hour, and he left an hour after Abhazra started driving, how long has Abhazra been driving for? Thank you, Armand. Was that Armand?
Yeah.
Oh, Zakem. Armand, do you understand why?
Because
Oh, no, I'm not asking you to explain it. I just want to make sure you're comfortable with why this is true.
I think I was 1 hour ahead.
Okay. Shyla, Carmen, does that make sense? Which part? Because it says here, Abhazra left the Science Museum 1 hour before Scott did. So if Scott's been driving 1 hour, Abhazra's been driving for a whole hour already before Scott started driving. Carolyn.
And then the distance to x and 1 time x plus 10 miles to x, right?
Yep.
And then together to add them, they're going to have to be 100 miles, then we are 100 miles apart.
You betcha.
And then 3x plus 10.
You betcha. So Abhazra's speed? 30 what? Miles per hour. Love it. Super duper. Awesome. Comments, questions, concerns, queries, conundrums, consternations? Danny.
So were the only questions we had, there were catching problems and there were opposite direction problems?
Or coming together.
Or coming together.
One of them you subtracted distances, one of them you added well, actually both you could technically add distances.
Catching they're equal,
Yeah.
and then,
If they're going towards or apart, then you have to add or subtract.
so if they're going apart, then you have to
Add them.
add them. So,
Well, if they're coming together, there's a couple different ways you can do the same problem.
but apart is absolutely add.
Yes.
And then,
Well, no.
no?
But apart and meeting somewhere in the middle is the same. Those are the same style of problem.
Okay.
Okay. Are we cool? Anything else? I said one more, but I want to make sure we're good. Okay, so hearing that we're good, let's finish the word problems here. We're going to finish this whole chapter. It's going to be lovely.
Today?
You betcha, this is it. And then I'm going to introduce you something called inequalities. It's going to be good. This whole time we've been dealing with equalities, where things are equal to each other. We're going to deal with inequalities, where things are not equal to each other. They're either greater than or less than to each other. It's going to be super duper. Okay, here we go. Rate of work problems. These problems are similar to motion in that they have a rate or a speed at which work is done. And therefore, some of the methods are going to overlap, but not nearly all of them. And the easiest way to show you guys how these things work is to talk about just a bunch of examples. So here we go. Colette and Flynn. They work on a boat. Goes on day trips around Vancouver. At the end of each day, the boat needs to be cleaned for whatever reason. Colette can do the job in 2 hours, but Flynn takes 3 because he's a slacker. How long will it take them if they do the job together? This is the style of question that we're going to be dealing with here. So, here is how we're going to set this thing up. We're going to chart it again. We're going to get Colette, we're going to get Flynn. Already, okay? Yeah.
So is Colette, are they saying Colette could do all of the work by herself?
She could clean the entire boat in 2 hours, yes.
By herself?
Yes.
And Flynn could do it in 3 hours?
Yes.
Okay. So together they're cleaning the boat. Okay.
Okay, so yeah, that actually leads me to the question I was going to ask you. What kind of number are we looking for here?
A smaller one.
Smaller than?
Definitely smaller than 3, but maybe, no, it's smaller than 2, I think.
It's got to be smaller than 2.
Yeah.
Because if Colette can do it by herself and assuming Flynn does actually help,
Right, yeah.
we're going to assume that the answer is going to be less than 2. Okay? Sorry? What's a slacker? Someone who's lazy. Doesn't work as fast. Okay. So, let's talk this through. Anyone have... Oh, and there's one more thing that we're going to assume here. Okay? When you're doing these kinds of questions... I know it wasn't you. You're fine. Let's assume that this is you. Put yourself in the position here of Colette. Okay? I am Flynn. You're cleaning the boat. You and I are going to clean the boat together. You can clean faster than me. How are we going to divide the work? How would you want to divide the work with me? 50-50.
Yeah.
You're going to do half the boat. I'm going to do half the boat. Which means you're going to be done your job when? In an hour. And I'm going to work an hour and a half, which means the total amount of work done is 2.5 hours. But that doesn't make sense, does it?
No.
So the thing that you have to assume with all of these questions is
But they're all cleaning the whole boat?
everyone works until the job is done. And what that means is this: we're not splitting the boat up 50-50. You work faster than me, and so you're going to work at your speed until you're done, and I'm going to work at my speed until we're done. Obviously, you're going to clean way more than I am, but we're going to get out of there quicker. So that's how we have to think this kind of thing through. It's not about equal division of labor. It's about working as fast as we can to get the job done. Okay? So we got Colette, we got Flynn. We're going to break this thing up into 3, and we're going to talk about how we set these up. The middle one, just like in the speed one, where we had D, V, and T, this one is going to, the middle column here is going to be the speed at which someone cleans. But generally, when we talk about how fast someone cleans, we don't talk about their speed or velocity at cleaning. We typically talk about the rate at which they clean. So this one is going to be the rate. And rate is always measured as a per what? If it's like a speed, it's always, yeah, we're always going to referencing as a per hour. So how are, the other thing we're going to include here is a column to record the times. In this case, Colette can do the job in 2, Flynn's going to take 3. Oh, cool. So how are we going to deal with the rate? Where's the, how is the, these 2 columns are going to be related, how?
They're going to equal how much of the boat is cleaned?
Kind of.
Okay.
Kind of, yeah. 10 me, did you have a thought?
Like, since that's the time, like, you have to find a rate behind, like,
Yes, I do know what you mean. So here's the question. What are these 2 doing? Cleaning what? A boat. One boat. Okay? So the rate at which this is going to be done is it's going to be 1 boat cleaned per 2 hours. Same with Flynn, except he's 1 boat cleaned per 3 hours. So you can look at it like this. Either it's 1 boat per 2 hours, or you can think of this as half a boat per hour. Those mean the same thing, right? Right? Does anyone not follow that logic? Okay, hearing we're all good, then we'll move on. The last piece we need here, and we're gonna combine their jobs together. Okay? So Colette's rate, leave some space, plus Flynn's rate leave some space, is going to equal what?
Those hours it takes.
You think so, but no.
Oh,
What are we doing? What are we adding together here?
no rates.
Well, it's not just the rates. There's going to be, what are Colette and Flynn combining to do? Clean a whole boat. So what these are going to represent is these are going to represent the fraction that each cleans of one whole boat. So then I need a multiplier here to figure out to help us change this rate per hour into just the job being done, the fraction of a job being done. I need a multiplier here to turn these rates into the amount of a job that was done. So what are we going to multiply these fractions by? By the time that they work together. So we're going to call that, I'm just going to call that n for whatever reason. And that's this last column here. This is, actually I'm going to call it h, because I can turn my n's into h's really easy. Because this column here is the hours worked. And in this case, they work the same amount. So now I've got 1/2 h plus 1/3 h. So this is the amount of the job that Colette does. This is the amount of the job that Flynn does to complete one boat. So how now do we go through and solve this thing? Danny.
You can find the common denominator for 2 and 3.
Which is?
6.
Yeah.
And then you have 3 over 6 and 2 over 6. H or have
Oh, let's get rid of those fractions. We're going to multiply by that.
just. Wait, what do you mean?
We're going to do
Oh, yeah.
we're going to do this.
Mm-hmm.
We're going to find the common denominator, then we're going to multiply everything by it. Here, what am I going to get? I'm going to get 3h, because 6 times 1/2 is 3. So 3h plus 2h equals 6. So 5h equals 6. So h equals 1.2. 1.2 what? Hours. Writing hours as a fraction does not make a lot of sense. So we're going to have h equals 1.2. That's interesting and all, but now I don't want hours. I don't want decimal hours. I want hours and minutes. So how do we convert this thing into hours and minutes? Anyone have an idea? Danny?
I have a question
Oh.
before.
Yeah.
Is it just a coincidence that there's 3h plus 2h and Colette works 2 hours and Flynn works 3? Is that just like a...
No, that's maybe. It might not always turn out that straightforward.
Okay.
How do we convert 1.2 hours into hours and minutes? Carolyn.
1 hour, no, 1 hour, then we have 0.2 hours, and then we just multiply 0.2 times 60.
So this section right here is going to give us the minutes. The 1 hour we already have, it's the fraction of an hour that we need to turn into minutes. So we're going to take the fraction of an hour, and as Carolyn said, we're going to multiply by 60. 2 times, or 0.2 rather, times 60 is 12. So 1 hour, 12 minutes to clean the boat together. And we're done. We cool with the procedure? Danny.
So you said that the hours worked with the 2 h's are equal to each other?
In this case, yes. Why?
Is that like the distance in the captioning problem?
No. It's like the time when they leave at the same time. The other assumption we're making here is that Colette and Flynn, unless it says otherwise, started working at the same time. Yeah. Flip the page. Let's do another one. Okay, so
Using slacker so much. This is not a slacker.
we're going to change this question a little bit. Tim, it takes 4 hours to paint a room. It takes Bob 3 hours to paint the same size room since he is not a slacker. How long will it take them to get the job done if they work together? This is the part of the question we're going to change. We're going to go here if. We'll scribble that out. Slightly different kind of question. We're going to go here if Bob joins Tim after $30 minutes. There's a lot going on with this question here that I've just now added. Okay? So these things we're going to set it up the same as we did before. We're going to have Tim. We're going to have Bob. Tim and Bob. We're going to have the time that they worked individually. We're going to have their rates. And we're going to have their hours worked. So, what do we know? Bob can do it in 3. Tim can do it in 4. Nico, wake up. En anglais, man. S'il vous plaît. Tim can do it in 4. Bob can do it in 3. So what's their rates? So it's going to be 1 over 4. He can do a quarter of the job in an hour. And Bob can do a third of the job in an hour. Now here's the tricky one. Their hours worked.
It's 30 minutes. Bob is 30 minutes less than, or it's X minus 30, or, wait.
So you're going to call Tim X, and you want to call this X minus something?
Yeah.
Okay.
Wait, would you divide, no.
Okay, so
Decimal for 30, decimal divided by 60.
it would in fact be minus 0.5. Okay. Okay, so if this is given to you in minutes, I gave this to you in minutes. To convert minutes to hours, we do what? Divide by 60. So 30 divided by 60 is a half, which we're going to write as a fraction here, 0.5. So Danny then said that Tim worked X hours, so then Bob is working a half hour less than Tim, because maybe, I don't know, maybe Bob he showed up to work a little late that day, or maybe he took a longer lunch, I don't know. Maybe Tim's the slacker, but, maybe Bob went to pick up lunch for him and Tim. So here we go. Let's set this up. We're still looking at their rates times their times. So 1/3 X minus 0.5 now equals, how many rooms are they painting? 1. Danny.
So you gave us, I don't know if this is what you gave us minutes, maybe you gave us hours.
Then we wouldn't have had to convert anything.
Oh, okay, we would just,
If everything is given to you in hours, then you wouldn't convert.
X minus 1?
Yes. No, X minus, I would have said after 0.5 hours. If I still wanted 30 minutes, or maybe if I say if Bob joins Tim after 1 hour, then it would be X minus 1, yeah.
Oh, okay, that's not bad.
Okay, so our first step, is there confusion in the back corner? Because this was given to you in minutes, and everything else is given to you in hours. So we want to be consistent with our times. I heard Ria say something similar to what I just said. I heard it. But that doesn't mean you need to be smug about it. So what am I going to do first? Carolyn. Estimate?
We could also do multiply that one.
We could also do that first. Let's just jump straight into it. Where the lowest common denominator of 3 and 4 is 12, as Carolyn's already said, so we're going to multiply everything by 12. Multiply by 12, multiply by 12, multiply by 12. Careful how you do this. This right here was the same kind of thing I gave you last week and told you to be real careful how you multiply this middle section.
Do you distribute the 12 into...
No, that is exactly what you do not do. Yes, you multiply the 12 just to the thing out front. 12 times a third is? X minus 0.5. Okay, now let's go back to the beginning one. A quarter times 12 is? So it's going to be 3x, and that's going to equal 12. Now what? Kyla. Distribute. 3x plus 4x minus 2 equals 12. I'm going to group and I'm going to add 2 at the same time here. So I'm going to do that. I'm going to group these two. So it's going to give me 7x equals 14. Divide by 7, x equals 2 hours.
And then we do 2 minus half an hour for Bob.
So we just found out that Tim worked 2 hours and Bob worked 1.5 hours. We write our sentence and we are done. Or you could say something like they get the job done 2 hours after Tim started or 1.5 hours after Bob started. You don't necessarily have to give me both times. Sorry? Yeah, Tim worked 2 hours, Bob worked an hour and a half. No, they finished 1.5 hours after Bob started, or 2 hours after Tim started, because they finished together. Okay. With this one, with example number 2, how is example 2 different than example 1? Sorry, yes, how is example 2 different than example 1? It's in minutes. Okay, so the only difference here is when you're dealing with your time, I will not do this whole question. Time, rate. If you can choose to convert this thing into hours, but if everything is given to you in minutes, as long as you remain consistent, you don't have to convert. You only have to convert if both of the things show up here. So for this one, we could say the time, we've got James and we've got Jeff. James's time we could say is 40 minutes. Jeff's time is 50 minutes. Yeah, the rate then is going to be a rate per minute, absolutely. So it's going to be 140, and this is going to be 1/50th. And then this last column isn't going to be hours worked, it's going to be what? It's going to be minutes worked. You only have to convert if there is a mix of units. If I give it to you in hours and minutes, then you got to pick one and keep it all together. But if it's all given to you in hours or if it's all given to you in minutes, you can just work in whatever time frame they give you. So that's all I'm going to do for example 2. It's exactly the same as the first one we did. Flip the page, let's do one more. I lied. We're going to do 2 more. Okay, I would like you to, before we finish, very carefully, before we do this example, I would like you to very carefully draw a horizontal line halfway between the bottom 2 dots, all the way across the page. Why? For no reason in particular. It's totally arbitrary. Just do it. And then underneath that line, right in the middle, I want you to draw a straight line vertically down. For no reason in particular. I'm just crazy. Okay, example 3. Here we go. Slide it back up. This last page here, I'm going to show you I'm going to actually do one whole version of a different kind of question. And then the bottom 2 squares, yes, obviously I had a purpose for that. What I'm going to do in the bottom there is we're going to discuss what ways I could make this more difficult for you. But we're not actually going to do any of those questions. We're just going to write out an example of what one could look like. And we'll leave them for you to play with. So, Kyra mows a lawn in 40 minutes. When she forces her boyfriend to help, they finish the job in 24 minutes. Okay, so how is this one different? Danny.
The variable isn't the amount of hours, minutes that they're working, but it's what his rate per minute is and how many minutes he would have worked on his own.
Right.
That's the variable.
Because we want to find out, since she's probably going to sunbathe next time anyway,
Right.
how long her boyfriend is going to have to work alone. Mm-hmm. So let's fill out the chart. We've got Kyra, who's just going to sunbathe next time. We've got boyfriend, who's going to have to work all alone. Here we've got their times. Here we're going to have the rate. In this case, yep, it's going to be per minute. And then minutes together. Okay, so let's fill it in. What do we know?
Wait, you said minutes together.
Yep.
But we know that she can mow one in 40 minutes on her own.
So her time is 40 minutes.
Yeah, sorry.
So then what's her rate?
40 minutes. Or sorry,
1 over 40. Yep. So, and we know their time together.
Right.
It's going to go there, and it's going to go there. So what are we looking for? Where's our variable going to go? We want to know the boyfriend's time. So let's call that x. So what's his rate going to be? It's going to be 1 over x. So let's set this up the same way we did before. Before, remember, we multiplied the rate by the amount of time they worked together. So this is going to be 140 times 24 plus 1 over x times 24 equals 1. What are we going to do? Yep. On the common denominator of 40 and x is? It's going to be 40x. Good. Multiply everything by that common denominator. So what's our first term going to be? It will, in fact, be 24x. Good. My 40s are going to cancel, leaving me 24 times x plus what? 40 times 24, which incidentally is 960. And that's going to equal 40x. So solving this thing, I'm just going to go fast here. We're going to subtract 24 on both sides. We're going to get 960 equals 16x. Divide by 16, divide by 16, and we're going to get that x is equal to 60. So what have we just found? The time it takes for the boyfriend to do it alone. The boyfriend takes 60 minutes to mow the lawn alone. Okay, cool. Sorry? You could say 1 hour, yeah, same thing. So this is the last style of question that we're going to do kind of collectively as a class. There are a few ways I could make this more difficult. I could make this particular question more difficult by telling you not what their time together would be. I could tell you their time together, that maybe I say something is, it takes them 30 minutes if the boyfriend shows up 20 minutes late. So then you have to deal with, you know, all sorts of things, right? So then Kyra's time would be, I don't even remember the numbers I just said. That would be a really nasty thing. I won't do that. There are, though, a couple other like distinctly different styles of, maybe not distinctly different, a little bit different styles of question I could ask you to make these rate of work problems a little bit gnarlier. All of these ones have involved two people. One easy way for me to amp up the question is to do what? Sorry? I can add more people. If I do that, how is the question going to change categorically if I just add more people? Not necessarily more variables. Hey, hands up. Carolyn, how's it going to get different? If it's 3 people, yeah. So, but we can keep going, right? Maybe instead it's Kyra, her boyfriend.
And his ex-girlfriend.
Whoa. I was going to say sister. Maybe sister's boyfriend. Wow. Yeah, maybe his boyfriend's ex-girlfriend. Why not? Mowing the lawn has never been so entertaining. Everyone shows up with their lawnmowers, right? This is the only difference. Okay. There is another way I can make this more interesting. Can anyone think of how else I could take this rate of work kind of problem and make it more irritating?
Just put the variables everywhere.
No, I don't want to do that. Like it's a change to, it's a bigger change than that.
Okay. Oh.
It's a change to the style of question.
How many items?
That's an easy. That's like a half change. Maybe instead of if Kyra mows the lawn in 40 minutes and her boyfriend helps, they can do the job in 24. Oh no, that's a bad one. Maybe let's go back to Bob and Tim. Tim takes 4 hours to paint a room. Bob takes 3. How long will it take them to paint 5 rooms?
Oh, you just multiply that by.
Then the only difference is it's going to equal 5. That's the only thing that changes is the equal piece at the end. So that's a really easy change to do.
The whole question just 1 and then.
There is a bigger change I can do to change the question at a more fundamental level. But I'm going to, and so you will want to see what this. Kyla. Okay, guys, listen up. Ooh, no. Nah, no, different than that even. No, I'm not going to add breaks. What have we assumed about everyone involved for all of these questions? Hold on. Hands up. Rebecca? No. Kyla? That would be challenging her. I'm not going to do that to you. What? We're running out of time here. You guys are going to have more homework if you can't figure this out. Ty, what are we assuming? Nope. We already made that assumption at the beginning. This is a new assumption. Sorry, Nika? No. No.
Hours and minutes?
Kyla?
What if the work is divided and then we have to add the
No, we're not going to do that. No.
Their rate changes?
We're assuming, ladies, I'll tell you this because we're running out of time. We're assuming, ladies, what are we assuming, Riley?
Aren't you assuming that everyone's doing work until the end?
We already established that. That was the first thing we assumed. The other thing that we're all assuming is that everyone is doing work that is helpful to complete the job. What if Tim and Bob are painting rooms and Tim is painting over Bob's work or Bob is painting over Tim's work? Or even worse than that, let's say what if this? So here's the question. What if, no, just let me write this down. What if one person or thing works against the others? Okay, so a classic example of this, ladies and gentlemen, is like I've got multiple hoses filling a pool.
Right. And then this one back.
And the drain is open. How quickly will the pool fill if I've got two hoses, or maybe there's a leak? If two hoses are filling it and there's a leak, how long is it going to take me to fill the pool? How is this going to change the setup of the question? We have to subtract. I love it. Let's write it at the bottom. Let's write it right here. You will have to subtract and I'm going to put it in quotes here, the contribution of the detractor. Okay. No. Just forget this ex-girlfriend. I'm going to start asking questions if you keep harping on that ex-girlfriend thing. Okay? What if one person or thing works against the others? You subtract the contribution of the detractor. It's true, yes.
So, if something, like let's say a bathtub, there's like 3 hoses in the bathtub, filling up the bathtub, and they're all filling up the bathtub, I don't know, like this is exaggerated, but like 1 inch per minute is each hose. So together they're 3 inches per minute. But then the drain is draining out 1
half an inch.
What can you say? 1 inch of water?
Well, then the drain completely cancels out one hose.
Right.
So then you just ignore that and do the other hose.
Yeah. Okay. That's all.
Okay, so here's what I'm going to do. I want you to do this. You're going to do the following things. No, actually there's 10 questions. And I am going to assign one second. 3 pumps that work together. All of it. You know what? No. We're going to do this page evens. That's only 2 questions. And you're going to flip the page again. And you're going to go here. And you're going to do all of these ones. That's 8 questions instead of 10 questions. Give it a shot. These ones actually go a lot quicker once you get the hang of things. But I want you to take a look at all of it. If you don't get the hang of it, it's going to be real slow. We'll help you with it tomorrow. Have a good day, guys. We'll see you later. Do what you can before the concert. Like you're going to a concert or you're playing in the concert? Nice. What do you play?